Topic 8, Probability. Subtopic 8.1, Events and Probability. Learning outcomes. At the end of this lesson, students should be able to A. Define the concept of experiments, outcomes, events, sample spaces and random selections, state the basic laws of probability, and find the probability of an event. Okay, so suppose that there is a blue, a red, and a black pen. What is the chance of choosing a black pen? That is an example of how you use probability. So the definition of probability is the chance of an event occurring, playing games or observing the occurrences events. So for example, probability is used widely in number forecast, lotteries, slot machines, card games. It is also used in fields of insurance, investment, weather forecast, economic planning, marketing, finance, and business. So what is random experiment? It is a process leading to at least 2 or more possible outcomes. Uncertainty as to which outcome will occur. We don't know what outcome will occur. For example, if we toss the coin, so we don't know if we're going to get a tail or head. When a die is rolled, we don't know what number will come out. It's either number 1, 2, 3, 4, 5, or 6. Or another example, when a customer is asked which one of the two products he or she prefers. Okay. Then what is outcome? Possible outcomes of a random experiment are called the basic outcomes. For example, just now I said about a coin is tossed, kan? So bila kita toss a coin, we're going to get either a head or a tail. So head or tail is the outcome of the random experiment. Okay. So sample space, what is sample space? A set of all basic outcomes. Okay, event. So what is an event? Event is a set of basic outcomes from the sample space or the experiment. An event is a subset of the sample space. Okay, simple event that includes one and only one outcomes from an experiment. And compound events, more than one outcomes. Okay, we're going to look at the example. Example 1. So if the experiment, if we toss a coin once, so what is the possible outcomes? So the possible outcomes are head, either we're going to get a head or tail. So sample space is all possible outcomes. So we're going to put head or tail lah. So event, so apa event dia? So let's say the event is getting at least one head.
So event kita ni adalah simple event since we only have one outcome.
So second experiment, tossing a coin twice. So the possible outcomes are head, head-tail, tail-head, or tail-tail. So sample space, as I said just now, is the list of all possible outcomes. So we're going to put with the curly bracket. So let's say the event is getting at least one head. So the compound event, the event of getting at least one head is just 3. It's either we're going to get or both head, tail, or the first one is tail and the second toss baru kita dapat head. The third experiment is rolling a die once. So if we roll a die once, the possible outcomes are 1, 2, 3, 4, 5, and 6. So the sample space, kita akan listkan all the possible outcomes into the curly bracket. Okay, let's say the event A is event of getting a prime number. So what is a prime number? A number that is greater than 1 and can only be divided by itself. So 1 tak include lah. Number 2 is a prime number. Number 3 is a prime number. 4 is not a prime number because it can be divided by 2. 5 is a prime number. 6 is not a prime number because it can be divided by either 2 or 3. So the compound event is 2, 3, and 5. We're going to put it in the curly bracket. Okay, the fourth experiment or the last experiment, taking a drive test. So the outcome is either we're going to pass or fail. So the sample space is pass fail is put in the curly bracket. Okay, sample space for an experiment can be illustrated on a Venn diagram, tree diagram, or a table. So for example 2, the experiment is tossing a coin twice. Okay, so when we talk about tree diagram, it must start from the same beginning. So starts from here. The possible outcomes are either we get a head or we get a tail. But that is just for the first toss. So we have to toss the coin twice. So for the second toss, the first toss we get a head. So the second toss, there will be 2 possible outcomes. It's either getting a head or getting a tail. Same happen when we get tail in the first toss. When we toss the coin twice, at the second toss, we might get a head or we also might get a tail. So the possible outcomes are head head or head tail or tail head or tail tail. So this is how we put our sample space. So Venn diagram, what is a Venn diagram? So we're going to put all our outcomes in a circle. Okay, S means sample space. So if we illustrate our experiment in a table, okay, we can also illustrate our experiment by using table. So let's say this is our first toss. This is our second toss. Okay, so if our first toss is head and our second toss is also head, so we're going to write our answer, our outcome as H head. If our first toss is tail and our second toss is head, we're going to write our answer as TH, tail head. Same goes if we have first toss as head, second toss we get tail, so we're going to write our answer as head tail. And if we get both first toss and second toss tail, so the way we're going to write our answer is tail tail. Okay, next, the experiment of getting odd numbers when rolling a die once. We know that a die, when we roll a die, the outcomes are 1, 2, 3, 4, 5, and 6. Okay, but the event of getting odd numbers, nombor ganjil, is number 1, number 3, and number 5. So the possible outcomes of getting odd numbers is 1, 3, 5. Okay, so this is a tree diagram. Okay, there are 6 possible outcomes. Okay, if we illustrate our experiment by using Venn diagram, so we know that the sample space, if we roll a die, there are 6 outcomes, 1, 2, 3, 4, 5, 6. But since the event is just getting odd numbers, so the circle means odd numbers. So the odd numbers are 1, 3, and 5. So other than the odd numbers, which is the even numbers, we're going to put it outside the circle, but still within the sample space. Okay, so that's why 2, 4, and 6 is put outside the circle. And there is no, we can't illustrate this experiment by using table, because usually we're going to use table when we have like 2 categories. Okay, but if we roll a die, we don't have 2 categories. Alright, third experiment. A bag contains 3 red balls, 2 blue balls, and 5 yellow balls. The experiment is to draw a ball from the bag. Okay, so we're going to draw 1 ball from the bag. So the possible outcomes is either we're going to get a red ball, a blue ball, or a yellow ball. So the outcome is red or blue or yellow. Alright, so to illustrate using Venn diagram, so the sample space, okay, we draw the sample space. So inside the sample space, we have 3 possible outcomes, either the red balls, the blue balls, or the yellow balls. Okay, there are no other colors lah. So that's why there is no other number of or letters outside the 3 circles. Okay, and we can't use table to illustrate the experiment since, like I said just now, we don't have two categories, different categories. Okay, so another experiment to look at, two dice are tossed. When we toss a die, we know that we're going to get, we know we're going to have 6 possible outcomes, 1, 2, 3, 4, 5, 6. But since we have two dice to be tossed, so we're going to consider the first toss and we're going to consider the second toss. For the second toss, we also have 6 possible outcomes, 1, 2, 3, 4, 5, 6. So the outcomes will be 1, 1, or first toss 1, second toss 2, or third toss 1, second toss 3, and so on. Okay, we cannot use Venn diagram to illustrate this experiment, but we can also use table. Okay, even though we have the same category, but there is two events going on, toss first die and toss second die. So when you toss first die, we get 1, toss second die, we get 1, to write our outcome as 1, 1. When we toss the first die, we get 2, toss second die, we get 1. So we're going to get, the outcome is 1, 2. And so on, just fill in the table. So overall, for this experiment, we have like 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 6 times 6, 36. Based on the table, we're going to get 36 outcomes from this experiment. Okay, so it is much easier to use table compared to use tree diagram for this experiment. So it actually depends on the experiment that we have. Certain experiment, so actually it depends on what experiment we have. Sometimes it's better to use tree diagram, especially when it involves flow of events or flow of actions. And we usually use table when we have like two different categories. Yeah. Or two things at the same time. Then we use table. Okay, next, we're going to have a look at the definition of probability and basic laws of probability. So the probability of an event A occurring is denoted by PA. Okay, so the definition of PA is number of possible outcomes in A divided by total number of all possible outcomes in the sample space. So we usually write as NA over N, as S represents the sample space. So basic laws of probability. Okay, the probability of A is in between 0
to 1.
If we have PA equals to 0, meaning that the event is an impossible event, impossible for the event to happen. If PA equals to 1, meaning that the event is a sure event, surely that event to be happening. Okay, and A prime means that the probability A doesn't happen. So PA doesn't happen, plus probability of A equals to the total probability lah. And we know that the total probability is 1. The sum of probabilities of all events for an experiment is always 1. Finding the probability of an event. So we look at example 3. So a box contains 8 white chalks. A teacher is drawing a chalk from the box. Find the probability that the chalk is white. Okay, so let W be the event of drawing white chalk. Okay, so number of sample space 8, since there is 8 chalks altogether in the box. Okay, number of available white chalk is 8. So probability of getting white chalk when we draw chalk from the box is number of white chalk divided by number of all chalks in the box. So the answer is 8 over 8, which equals to 1. So when we get probability equals to 1, meaning we're definitely going to get a white chalk when we draw from the box. Okay, not white. So not white, meaning we have to find probability W prime. It also means 1 minus probability of W. So 1 minus probability of W, which is 1, So 0.
It is impossible not to get white chalk.
Okay. Let B be the event of getting blue chalk from the box. So B is an impossible event, tak mungkin terjadi. So the probability of getting a blue chalk is 0. Example 4. Two dice are tossed. Find the probability that A, the sum of two numbers, is 8. Okay, so for this experiment, we're going to use table. Okay, this is what your table should look like. For the first row, we're going to put the first die. For the first column, we're going to put the second die. The outcome is sum of the outcomes when we toss the dice. Okay, when we get 1 as a when we toss first die we get 1, when we toss second die we get 1, so the sum of those two numbers is 2. When we toss the first die we get 2, when we toss the second die we get 1, so the sum of those two numbers we get 3, and we get 4, 5, 6, 7 and so on. Alright, so we get first die 1, second die 2, 1 plus 2, we get 3. First die 2, second die is 2, so 2 plus 2 we get 4, and so on. That is how we fill in the tables. But right now, the question asks us to find the probability when the sum of the two numbers is 8. So let's have a look when will we get sum 8. So this is the time when we get sum as 8. Alright. So let A be the event of getting 8 as the sum of two numbers. So in this case, we're going to get A when our first die is 2, second die is 6, or when our first die is 3, second die is 5, or when the first die is 4, second die is 4, or when the first die is 5, second die is 3, and lastly, when the first die is 6, the second die is 2. So probability of getting 8 as the sum of two numbers is 1, 2, 3, 4, 5. 5 over number of sample space. So altogether we have 36 sums. So 5 over 36. This cannot be simplified, so our answer is 5 over 36. Okay, next, B. The sum of two numbers are prime numbers. So prime numbers is a number that is greater than 1 and can only be divided by itself. So the prime numbers is 2, 3, 5, 7, 11. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So B is the event of getting prime numbers as the sum. So number of getting prime number is 15. 15 times. So probability of getting B equals to 15 over 36, which can be simplified as 5 over 12. Example 5. 3 unbiased coins are tossed simultaneously. Find the probability of getting A exactly 2 heads. So untuk example 5, kita boleh illustrate the event by using tree diagram. Kita tak guna table macam example sebelumnya sebab ia melibatkan lebih daripada 2 benda lah. 3 coins dibaling pada masa yang sama. Okay, so macam mana kita nak buat tree diagram? Mula-mula kita start dengan bila baling first coin. So, untuk first coin boleh jadi bila kita baling dapat head ataupun boleh jadi bila kita baling dapat tail. Dan kita tengok bila kita baling dapat second coin, untuk second coin tu, kita baling mungkin first head dia dapat head, second toss dia dapat head juga. Atau mungkin first coin dia dapat head, second coin dapat tail. Atau boleh jadi bila first coin dapat tail, second coin dapat head, first coin dapat tail, second coin dapat tail juga. Okay, tapi sebab kita ada 3 coin, so kita kena consider satu lagi coin. So again, ada 2 outcomes, head, tail, head, tail, head, tail. Last sekali head ataupun tail. Okay, so sekarang ni kita nak cari probability of getting exactly 2 heads. Okay, so semua sekali kita akan ada 3 outcomes lah. Head, head, head. Head, head, tail. Head, tail, head. Head, tail, tail. Tail, head, head. Tail, head, tail. Tail, tail, head. Tail, tail, tail. So kalau kita kira 1, 2, 3, 4, 5, 6, 7, 8. Ada 8 outcomes altogether. So number of sample space, number of all possible outcomes adalah 8. Okay, so exactly 2 heads. So ni adalah event kita. The event of getting exactly 2 heads. So number of the event getting exactly 2 heads. So first ni tak boleh lah. So yang second case, third case, yang ni second ni 2 head juga. Ni 1 head, tak ada head langsung. Alright. So kita ada 3 ada 3 susunan lah yang membolehkan kita dapat exactly 2 heads. So the probability of getting A equals to number of A divided by number of sample space. Dalam kes ni 3/8. Tak boleh simplify, so this is our probability. Okay, so kita tengok yang seterusnya. Yang seterusnya event kita at least 2 heads. So bila at least 2 heads bermaksud boleh jadi paling kurang 2. So yang tadi tu 1, 2, 3. Ataupun boleh jadi 3 coins bila kita baling dapat head. So ini adalah the only time yang bila kita baling dapat 3 head lah. Okay, so kalau kita kira dekat sini number of getting at least 2 heads ada 1, 2, 3, 4. 4 kali. Alright, so probability of getting at least 2 heads adalah number of getting 2 heads, at least 2 heads divided by number of sample space. So jawapan kita adalah 4/8. So 4/8 can be simplified as 1/2. Okay, kita tengok yang seterusnya. Find the probability of getting C at most 1 head. So bila at most dalam erti kata lain, paling banyak 1 head lah. So sama ada 1 head ataupun tak ada head langsung. Alright, so dalam kes ni kita akan tengok kes yang 1 head. So ni 3, 2, 1 head. 2, 1 head. 1 head. Ni tak ada head langsung. Alright, so number of getting at most 1 head ada 1, 2, 3, 4. 4 kali lah. So probability of getting at most 1 head is 4/8. Number of C divided by number of sample space. So 4/8 can be simplified as 1/2. So ini adalah jawapan untuk probability of getting at most 1 head. Example 6. Suppose that a die is biased or loaded so that 3 appears twice, but the other 5 outcomes are equally likely. What is the probability that an odd number appears when we roll this die? Okay, biasa kita jumpa unbiased die. So, bila unbiased die, bermaksud probability untuk dapat setiap number tu 1, 2, 3, 4, 5, 6 adalah sama. 1/6, 1/6, 1/6 and so on. Bila kita jumpa case di mana a die is biased, bermaksud die tu, dadu kita tu dia dibina so that berat kepada certain number. Macam case ni, die is biased so that 3 appears twice. Bermaksud, bila kita baling, kemungkinan untuk nombor 3 terkeluar lebih banyak. Okay, so kita tahu kita ada 6 outcome. 1, 2, 3, 4, 5, 6. Okay, so kita tahu probability untuk dapat 3 ni 2 kali daripada yang lain. So, mungkin kalau yang lain tu probability dia P. Probability untuk dapatkan nombor 3 adalah 2 kali P lah. Dan dia kata the other 5 outcomes are equally likely. Sama yang lain. Okay, so dia tanya dekat sini, what is the probability that an odd number appears when we roll this die? So, odd number, nombor 1, 3, 5. Alright. So, first kali kita kena carilah P ni berapa. Kita tahu summation of all probability equals to 1. So, P plus 2P plus P plus P plus P equals to 1. So, 1, 2, 3, 4, 5. 5 tambah 2, 7. So, 7P equals to 1. 7P equals to 1. So, P equals to 1/7. So, ini adalah value of P. So, kita nak cari probability odd number. So, probability of getting odd numbers is when we get number 1, when we get number 3, and when we get number 5. So, probability of getting 1 is P lah, which is 1/7. Probability of getting 3 is 2 times P, so 2 times 1/7. Plus probability of getting 5, which is P, 1/7. So 1 plus 2 plus 1, kita akan dapat 4/7. So this is the probability when the odd number appears.